Okay, there's the answer. Pause this and copy that down. If you had trouble, it's okay. Just ask me about it in class. Let's see. Okay, we have two cases we've done so far. Case one is linear factors, no repeats. No repeats. So, an example is, x plus 2 whatever. So it's going to be something over x plus 3 plus something over x plus 4. Now, case 2 is also linear factors, but there are repeats. Repeats present. So if I had x plus 4, say, cubed. Oops. So what you do there is you would make that a bit shorter. Okay. You would take x plus 3 and say, well, that's not repeated. This one here is not repeated. So all I have to do is give it one letter. Now, because I have a cube right there as my exponent, that means I'm going to need 3 letters. B, C, D. And what you do is count your way up the powers. Like so. Okay, so pause and copy. So what I want you to notice, we've been using these, kind of algebraic facts. One thing that I want to underline is that the degree of this polynomial is less than the degree here. So degree here is 1 linear, and this is a quadratic, so it's 2. Likewise here, degree is 1, on the bottom degree is 4. Okay, so that is not a coincidence, that is a requirement for these algebraic facts here. Okay, so to use these decompositions, the degree on top must be strictly smaller than the degree on the bottom. So let's write that down. Degree of numerator is strictly less than degree of denominator. And if not, well, we do long division. We do long division first. Okay. So let's do some long division. So that's my example here. X cubed plus x minus 1. Wait a tick, x to the 5, sorry, x to the 5, all over x cubed plus 1. So the degree on top is 5, and the degree on the bottom is 3. So we have to do what's called long division. If you did high school in French, then you did something a little bit different than what I'm doing here. But you can do whatever you want. It's not essential that you do the Anglophone way. I can follow the Francophone way too. Okay, so I'm doing a division. So let's remember how division works in green down here. If you have 2 into 7, what you say is it goes in 3 times. And then 3 times 2 is 6. And then you perform this subtraction. And you call this the remainder. So we're going to do pretty much the same thing here. So I put my denominator there. Just like over here, we had 7 over 2. For my numerator, I'm going to do something a little bit different. I'm going to notice that there are some terms missing here. I have x to the 5, but I don't have a x to the 4 term. So I'm going to insert it with a 0 in front. Likewise, 0 x cubed 0 x squared plus x minus 1. Okay, what this does is it helps all my work kind of stay arranged below here. Okay, so I'm going to follow what I did over here. I said 2 goes into 7 3 times. Now, up top here, I'm going to say x cubed goes into x to the 5 x squared times. Next, I said 3 times 2 is 6. Now I'm going to say x squared times this guy gives me x to the 5 plus x squared, which I'm going to put nicely arranged there. Okay, now I will subtract and get minus x squared plus x minus 1. Now, over here, I would say, well, 2 does not go into 1. So I'd stop and say, I have my remainder. Okay, likewise, x cubed does not go into x squared. So I stop and say, this is my remainder. And you just put an R there, it's fine. Okay, so what we get is that Let's go back to our green thing here. Seven over two is the quotient 3 plus the remainder divided by denominator. Okay, so the 3, the 1, and the 2 here came from the work I did over here. I'll do the same thing with my blue stuff here. I'll say the quotient is the x squared plus the remainder minus x squared plus x minus 1 divided by the original denominator.